Guys, Edgerton here, super pumped again to bring you guys another episode on my machine learning journey. Now, in this one, I actually I was doing this in school, and school isn't the best time to record, so I missed out on a little bit of documentation. But I think in the last one, I selected a project, which is I'm gonna make basically Google Translate, and then maybe add a few more features so that actually it can benefit me or some of the other people. Here's how I usually come about like implementing machine learning in my projects. I will maybe train my machine learning model on like a smaller data set, maybe a partial data set of the entire data set possible, and then come along and test that all in the Python environment alone. And then maybe I make that into a website, just make it into like a little Flask app, or I've actually never dealt with Flask before, so I might want to put it with Django, because I have done that before. I've done Django and machine learning before. It's really easy. It's really just the website stuff are a part, and then the Python code is another part. Yeah. But luckily here. But for the actual part that you implement the machine learning code, I'm actually having a big trouble because I don't quite know how to approach some sequence-to-sequence machine learning translation, basically. But luckily, I found this tutorial right here. How to develop a neural machine translation from scratch. And I find these tutorials really helpful because, to be honest, who the fuck is going to implement everything from the ground up, right? Like, there's really just no need to reinvent the wheel and then try to write all of the code yourself. It's really just gonna be, I think it's way smarter to just read stuff and then maybe tweak it a little bit. Like for example, this guy's model is not that complex. There's only like 5 layers or something. I don't know. There's something that's not as complex, and this guy's not using attention focus, whatever model thing. Which can increase accuracy by a lot. So I might implement those at the end, but so right now I'm just going to be doing this. So I guess today I will just try to implement this whole tutorial written right here, and then maybe make a few additions if I feel like it. So yeah, see you guys soon. Actually got some of the results right here. This little machine learning model that's trained by 10,000 examples is actually doing somewhat well. Let me pull this up. Yeah, so like, to be honest, I do take Spanish in high school, but my Spanish level, man, my teachers laugh at me. I mean, actually, she doesn't, but like, my Spanish is pretty laughable. So I don't really know like what causes the actual like this actor kind of means. So basically this thing right here is what we input into the model. This is what we expect it to output, but this is what it actually outputs. Holy cow, what's happening? So I'm making so there is some inconsistency here. I'm really glad that stuff like can you see Tom is working. I think that is really important, like the can you and you can, that kind of stuff, like the question kind of stuff. Yeah, as long as that logic's working, that's good. I don't really care as much as if the word itself is not getting translated perfectly. They want me, they mean me. They mean me. Yeah, that's not right. Well, again, 10,000 words not enough training. Keep listening, keep yourself. There's a chance I never saw the word listening, right? So this is a little small problem, but I don't think it's the worst. Still the money works right here. So what I'm gonna do next is, I think I'm gonna draw my board. Again, this is all done with the tutorial, right? So like, I don't really know a lot of stuff behind it. So I'm just gonna work on my board and write this down, and kind of be able to see on a macro scale what this is doing. even like deeper. Because right now I understand everything. I know that, you know, we are pre-processing our data set. We're cleaning the data set up so it's good for training, and then we go train, and then we get a model back. But I kind of want to know deeper than that. For example, the layers that are in the actual model. Um, oh, this is a big one. How can I improve it? Right, like can I make it thicker? This is not a confidence, so I gotta think about how can I make this better. I know that I can add stuff like the attention mechanism, which is basically training a mini neural network to identify which words should the particular RNN be looking at when predicting each timestamp, which will significantly increase accuracy. But this will be after I investigate the code and really understand what this is doing. Yeah, I got a model right here, and all I'm doing is really just copying the code to evaluate stuff. So I don't really know what's going on in the deep dungeons. So that's what I'll be doing next. And also, I'm interested in what is this blue score. I think I saw it in the Coursera course of this blue score being mentioned, but it was optional, so of course I skipped it. There's something I'm really puzzled about right now. I really don't understand it. So I've gotta, like, I'm still figuring out how, like, you know, it's really easy to just say, you know, we just pre-process our data, but I kind of want to know exactly how we do it. So give me a second. Spider is not running. So this right here, SPA, Spanish.txt, is our actual training data, right, or test data, however you say it. And we can see that between go dot and they dot, there's like no space whatsoever, and it really puzzles me, because then, like, how exactly does, and it turns out that if I just do read documents, if I just read document, it's gonna turn out to be like that right there. So it's already kind of like split. Right. And I just don't know how it splits when, like, right here it doesn't define it to be by anyhow there's a space or anything. I know that strip seems to be like a command that just removes the white space, and that puzzles me, because I don't think that's all it does. It somehow, actually, going one step before that, how does reading a doc automatically split into like that space right there, when in the actual text document there is like nothing here? So I just really have no idea, and I'm really confused. But I think it's a question I have to ask my Stack Overflow. Yeah, I can't just stick to this and like think my brain off. There must be some other reason, so let me get back to it. So I always think about the problem when I just went to the bathroom, and what I don't understand is, okay, I really gotta think this through. So we can't just build a model with plain text, because, you know, the computer cannot just process text. We have to convert it to integers, and it makes sense to me if we were just to map each word that happened in our data set. For example, if there's only 3 different unique words like the, cat, sat, then that means in our whole, we're gonna make a dictionary, and 0 is gonna map to the, 1 is gonna map to cat, and 2 is gonna map to sat, and that'll be it. And so we're gonna basically go through our whole array, look for the unique words, and then create an index for each. Create a unique, I mean not unique, but just index for each of them. So if there's 1,000 unique words, create 1,000 of them. And then I would imagine to represent to represent a word like the cat sat, then we're just gonna be doing, this will just be 0, 1, 2. Wait. Yeah, something like that. I think I'm missing something. I'm really missing the one hot encoder. I know it comes into play to some part, but I can't really remember right now. But anyways, the part that oh my god, I just got myself even more confused. But the part that confuses me is a tokenizer. The tokenizer in our example runs two methods. And after digging into the documentation and a little bit of Stack Overflow, oh wait. Okay, I was missing something. Oh no, I wasn't missing something. So basically, I call in two methods that the tokenizer already has in the keyword's pre-processing, and one is fit on text, and then one is tokenizer text to sequences. And I think according to the documentation, fit on text, what it's doing is that it is counting the, it is first of all assigning. This is really hard to explain. So it's not an index to word, but it's actually a word to index. But for each word, so for example, the cat sat, then in our tokenizer list, which we'll just call list for now, if we just do list cats, it will equal to 1 because there's one occurrence. And then if we were to do list of like Andrew, it's going to be 0. And then we call it this text to sequences thing, which I think, let me see again. Oh, and then it transforms, it then transforms that into text. This is really weird. I just got myself another layer of confusion. So first of all, my major confusion is that why the heck are we representing our words based on the frequency it appears? Because that should have no tie to the actual training process. So the frequency of each word appearing in the entire dataset should not have any effect on the individual performance and the individual mapping. So that got me really confused. I mean, it works, right? Like, it's still gonna be unique. It's still gonna be unique, right? Like this one, actually, it's not even gonna be unique. 2 words can appear only once. So yeah, I think it's, I'm reading documentation wrong. But, this is just really weird. Yeah, so okay, so fit on text is not creating anything, I believe. It's not returning anything. It's just creating a tokenized object. And it's going to update the internal vocabulary based on the list of words. And it's going to create a vocabulary index based on word frequency. And that right there is correct. So the list cat equals to 1 based on that. And so it's like all internal, and then when we call text to sequences, we gotta input in here some text, and at that text we're gonna look through all of the words in the text. So let's say the word that the text that we put in is hi, I am cat. Then I don't know, because like we never defined hi, but I know that for cat it's gonna turn into 1 because it is 1 here. That is internal memory. Which confuses me a lot because, like, what if running through our entire training set we figured out that, wait a second, it's not mapping, it's only the English. Okay, I might be wrong. But yeah, that's why I like to document. I like to see my confusion after I understand my stuff. So let's keep digging now. Oh, wait, hold up. Wait. This is so weird. What? Fit on text of this internal vocabulary based on listed text. This method creates a vocabulary index based on word frequency. So if you give it something like the cat sat on the mat, it will create a dictionary word index equals to 0, word index of cat equals to 1. It is a word to index dictionary, so every word gets a unique integer value. So this Stack Overflow question is not making sense because what the heck is it based on word frequency, and then it also gives you a unique integer value. But however it explains, it does write that, it writes with a so, even though there's not really logic beforehand. Lower integer means more frequent of the word. Oh yeah, it should be that lower integer generally means. I think I'm gonna lower my I'm gonna make my screen smaller so you guys can see this. But so right here it reads, it is a words index dictionary, so every word gets a unique integer value. But it does make sense when it says so lower integer means more frequent word, because if a word is super frequent, it's probably going to appear a lot earlier in the text. But it also has a chance of the word zebra being index 0 if that's the first word in your entire training set. But okay, this stresses me. I mean, this decreased my stress by a lot. Now that I consumed the whole thing and not just... So it was my fault though, because I only absorbed like the front and the surface. I didn't dig deep enough. And blamed on Nurik, my friend right here. That's my bad. So now a lot of things make sense. For example, so after we make the tokenizer and then we convert our whole entire string like line right here, which is a double array, into integers right here, we apply padding, which will go through each of the index in the double array, which means we're going through each of the pairs, and then padding it to the max length because we can't train if the length are different. We can't train like where each pair is like different size. So we look for the maximum, we'll make it that. That now makes sense a lot. So okay, so I'll basically go with the pre-processing part. Let's all just pre-processing, still got a lot to go. So according to the tutorial, we're only running the one-hot encoder on the training Y, and one-hot encoder is basically, to be honest, I don't really know the difference between one-hot encoder and the whole tokenizer crap. All I know is one-hot encoder seems to be a lot easier to implement, as shown in the code right here. Oh, I think we're camera zoomed in right now, but yeah, the code is actually really easy. You just gotta press type one-hot encoder. But okay, so then we got the data pre-processed because one-hot encoder turns the thing into integers, and tokenizer turned the training x and test x into integers. So now we keep going.